No-NOC networking, how to mitigate network attacks before they happen, presented by Neil Krowitz. Part 3, Active Solutions. In Part 1 of this series, I covered a simple approach for mitigating attacks. If you stop the reconnaissance early, then the subsequent scans and attacks are never generated. In Part 2, I showed a few simple ways to hide from discovery attacks. If the attackers cannot find your server, then they won't queue up your address for more invasive actions. If you implement this, then you should see about an 80% reduction in hostile network traffic. In this video, I'll cover more active detection techniques that further reduces the volume of scans and attacks. On my servers, I saw a 99.9% reduction compared to systems that do no blocking. In the previous video, I talked about ways to hide from discovery attacks. The attacker sends out a reconnaissance packet and listens for any reply. If your server replies, then they will add your system to the list of targets that will receive a more thorough interrogation. If you don't respond to the reconnaissance packet, then they assume that the address is not in use and won't queue up the system for more scans and attacks. Okay, so let's assume that your system is properly hiding from discovery attacks. Unfortunately, you can't always hide. If you're running any kind of externally accessible service, like a web or email service, then they can always query that service's port, and your server will always reply. At that moment, the attacker knows your service exists, and they can queue it up for subsequent attacks. However, your server knows something about them. You know their IP address, which you can use to check their network reputation. You see, every network address is assigned to a region, country, and service provider, and you can freely download these lists for doing real-time reputation lookups on your server. Some of these service providers have known bad reputations and are known to be hostile. These include cloud and proxy providers, because attackers often prefer to relay through someone else's computer rather than attack directly. Bulletproof hosting providers cater to hostile clients. They're called bulletproof because these companies do nothing to deter hostile usage and ignore any complaints. Bad actors can operate from these providers without any fear of being shut down. There are also known hostile or majority hostile service providers, where every packet from them, or almost every packet, is some kind of scan or attack. One of the big ones right now is Changwei. They geolocate to the tri-country region of Russia, China, and North Korea. If you want to see where North Korea is attacking from, take a good look at Changwei. And then there are the self-proclaimed researchers who don't really do research. Companies like Shodan, Binary Edge, and Shadow Server are constantly scanning and attacking every system on the internet. If you talk to them, they'll tell you that they are not attacking because they don't have the intent to compromise. However, there is no intent flag in the packet. If you look at the packets that they are slinging, they look no different from the known hostile providers. The only real difference between these researchers and the known hostiles is that the researchers attack more often.
Oh, burn.
On my servers, I maintain a list of these hostile services. These include individual IP addresses, subnets, and providers that are regularly used to violate my terms of service. If a client connects from any of these undesirable locations, I have the option to block, filter, or restrict access. As an example of this, let's just consider Tor, the onion routing proxy network. My photo forensics service permits people to upload pictures, but there are a few exceptions. No porn, no identity cards, nothing that facilitates an illegal activity, and so on. In the history of my service, Tor has never been a majority of the uploads. At best, Tor accounted for about 1% of the uploaded content. However, that 1% from Tor accounted for over 80% of the porn, including over 50% of the child porn that my service received. Overall, more than 90% of uploads from Tor violated my terms of service. When over 90% of content from a service provider is prohibited, it's not worth my time to track down the less than 10% who obey the rules. Instead, I just block all Tor users. When regular users visit my website, they see a homepage that permits uploads. When Tor users visit the same site, they see an access restriction. Tor is not a mandatory service, it's optional. That less than 10% of users are choosing to access my service from a known hostile provider. If you want to access my site, don't use Tor. Don't come from a known hostile service. Okay, so what if someone comes to my site from a provider with a better reputation? It doesn't mean you're a good person. It just rules out guilt by association. Can I still spot attacks before they happen? Of course I can. For example, I can watch the ports you access. You see, I have a server, I have a firewall, and I have well-known open ports in the firewall for accessing the running services. Regular users will always access the well-known open ports. Attackers, on the other hand, will scan for any open port. If they find any open port, then they will attack it. Will, that's future. If I can detect them scanning for ports, then I can hide all remaining ports from them. If I do it fast enough, then they won't find any open ports and won't attack the server. The thing to remember is that port scans are reconnaissance. First, they scan to find vulnerable surfaces, then they attack the services that they find. I looked for open source solutions that could detect firewall scanning. However, I didn't find anything that did what I wanted, so as you can guess, I built my own. I call it Nuzzle. It's a fast, lightweight packet sniffer that I've released as open source code. Nuzzle can detect lots of different types of common reconnaissance scans and attacks, and it works well with tools like fail2ban for real-time blocking. Okay, now I have a tool that can detect scanning. What I found was that about 70% of web attacks were preceded by port scans. So I implemented real-time port scan blocking with Nuzzle. The attackers scan my server, get blocked, and never find the real services. Within hours, the number of attacks was reduced by 70%, which is great. This is exactly what I expected. And keep in mind, this is 70% on top of the 80% reduction from hiding, so the total reduction is 94%. But it didn't stop there. That was after a few hours. By the end of the week, it became a 90% drop. And this makes sense if you think about it. The attackers add servers to their list of targets to attack. It took about a week for these queues to remove my network address. But it didn't stop there. That was after a week. After 9 months, it became a 99% reduction. I went from receiving over 5,000 scans and attacks every 5 minutes to seeing fewer than 50 scans and attacks every 5 minutes. That's an awesome result. And you don't need to block them for very long. 15 to 30 minutes is enough to see a 99% reduction in scans and attacks. Now when I look at my logs, I see entries like these. Each line shows someone scanning my server, and there are only a few scans per minute. Some scans come in rapidly from the same network address. Some come in every 10, 20, 30 seconds. And some come in even slower, every minute or 2 minutes. I guess these people think that if they scan you slow enough, then nobody will notice. However, even though they scan slowly, they will continue scanning for days, weeks, or longer. After a few weeks or months, they will change network addresses and resume the same slow scanning. The other thing I can do is map these network addresses back to the providers. Now we can see the well-known hostiles like Cheng Wei and Rosa, and the attacks from self-proclaimed research companies like Recyber, Census, Shodan, and Stretchoid. And if you notice, there are more attacks from these researchers than from the known hostiles. That's typical.
Oh, burn.
Okay, so what if they only scan my open ports? Can I still spot an attacker before they attack? Yes. For example, I can use packet profiling. Every IP packet has a set of flags and options. I can use those to identify things about the client. Just consider the TTL. The time to live field prevents infinite forwarding loops. The initial value is set by the sender, and each router reduces the value by 1 as the packet is relayed. If the value ever hits 0, then it means the packet cannot be delivered. Traceroute is a reconnaissance tool that maps out the route from the client to the server. It works by incrementally iterating over the TTL values. Traceroute first sends a packet with a TTL value of 1. The first router cannot deliver it, so the sender learns where the first router is located. Then it tries a TTL of 2. The first router reduces it to 1. The second router cannot deliver it, so the sender identifies the second router. Eventually, the TTL will increment enough to reach the server. Then the attacker knows how far away the server is and the route to the server. However, the server sees an incoming packet with a TTL of 1. That means it knows that the client is running traceroute. And since traceroute is a reconnaissance tool, it means the client is an attacker. At that point, the server can block, filter, or flag the client for additional monitoring. I can also profile the packet's TCP header. TCP connections begin with a three-way handshake. The client sends a TCP SYN packet, the server responds with a SYN ACK, and the client confirms with an ACK. The TCP header has a set of options and flags that are set by the operating system and are present in every TCP packet, including the initial SYN packet. Different operating systems use different options. Linux looks different from Windows, looks different from Mac. As it turns out, many bots and attack scripts have their own distinct set of options. I can look at the incoming SYN packet, see options that are associated with attack scripts, and block the attacker before they finish the handshake. I can stop the attack before it begins. Okay, so let's say you came from a good provider, you didn't scan my firewall, you found my open web service, and your packets didn't look suspicious. Can I still spot an attacker before they attack? Absolutely. For example, my web server uses HTTPS. That's HTTP over SSL, which is now called TLS. Just as TCP uses a multi-step handshake, TLS also uses a multi-step handshake. And that very first step in the TLS handshake is called the client hello. In the hello, the client lists the cipher sets that it supports. The server is supposed to look over this list and decide which cipher to use. That's how they negotiate the cryptographic communications. As it turns out, that cipher list is dependent on the client's application, TLS library, and operating system. Because of this, I can often detect the underlying operating system and application before the client completes the TLS handshake. Firefox looks different from Chrome, looks different from Safari, and so on. As you can guess, many attack scripts also use custom cipher suite sets. My server can look at the client hello's cipher set and determine that this set matches the zgrab application scanner. That's a reconnaissance tool. They are about to attack. And now my server can terminate the connection before the client completes the TLS handshake and before they can attack. In this video series, I've shown that it is very feasible to detect reconnaissance scans and stop attacks before they happen. By blocking simple discovery scans, I can reduce the number of attacks by 80%. With active blocking, I can reduce it to 99.8%. And early packet detection can reduce it by another 50% to 99.9%, which is incredible. This works because the scanners cannot reach the server and never add the server to their list of things to attack. Keep in mind, this 99.9% reduction does not stop the attackers from sending the first scan or trying the first attack. Instead, it stops any subsequent scans and attacks because the attackers found nothing. But I can still do more. In the next video, I'll cover application-level filtering and full-stack profiling. My name is Neil Krawitz, my company is HackerFactor, and I thank you for your time.